For decades, humanity has gazed up at the stars and wondered, is there another Earth out there? With billions of stars in the universe, each potentially harboring planets, the question of whether we are alone in the cosmos has captivated scientists, philosophers, and dreamers alike. Today, thanks to advances in technology and breakthroughs in astronomy, we are closer than ever to finding a planet that could host life, or perhaps even become a new home for humanity. But just how close are we? Could we one day discover a true Earth twin, or are we bound to find only distant worlds with faint resemblances? In this video, we'll dive into the science behind the search for another Earth, explore the cutting-edge technologies making this possible, and reveal what the latest data tells us about our quest. There are some exciting and controversial discoveries, and by the end, you'll have a better understanding of just how close we might be to finding a second Earth. The concept of an Earth-like planet. Before we can discuss finding another Earth, we need to define what we mean by Earth-like. Is it simply a planet that orbits its star at the right distance, the so-called habitable zone, where liquid water can exist? Or do we need more? Scientists generally agree that for a planet to be truly Earth-like, it must meet several criteria. It must be roughly the size of Earth, ensuring it has similar gravity. It must orbit in its star's habitable zone, where temperatures allow for liquid water. It must have an atmosphere capable of supporting life, ideally one that includes oxygen, nitrogen, and other gases similar to Earth's. It should also have magnetic fields that protect it from harmful cosmic radiation, just like Earth's magnetosphere. Finding a planet with all these characteristics is no easy feat. Of the over 5,000 confirmed exoplanets to date, only a handful meet even some of these criteria. The habitable zone, Goldilocks planets. When we talk about the habitable zone, we're referring to a range of distances from a star where a planet could have the right temperature for liquid water to exist. This zone is also known as the Goldilocks zone, because the conditions have to be just right, not too hot and not too cold. But here's where it gets controversial. Simply being in the habitable zone isn't enough. Venus is technically in the Sun's habitable zone, but its thick atmosphere creates a runaway greenhouse effect, making it inhospitable. Mars, too, is on the edge of this zone, but its thin atmosphere means it can't retain liquid water on its surface for long. Scientists now argue that other factors, such as planetary mass, atmosphere composition, and even the type of star, play just as significant a role in determining a planet's habitability. In fact, recent data from NASA's Kepler mission shows that potentially billions of planets in the Milky Way alone fall within their star's habitable zone. So, while being in this zone is a good start, it's just the beginning of what makes a planet Earth-like. Kepler, TESS, and the hunt for exoplanets. The hunt for another Earth accelerated in 2009 when NASA launched the Kepler Space Telescope. Kepler's mission was straightforward: to search for planets around other stars by detecting tiny dips in brightness as a planet passed in front of its star, a method known as the transit method. In its 9 years of operation, Kepler discovered over 2,600 exoplanets, many of which reside in their star's habitable zone. Kepler's successor, TESS, Transient's Exoplanet Survey Satellite, was launched in 2018 and is designed to search for exoplanets around the nearest and brightest stars. TESS has already identified hundreds of candidate planets, and it is expected to find thousands more. One of the most exciting discoveries made by TESS is a planet known as TOI 700d, located about 100 light-years from Earth. This planet is within its star's habitable zone, and while we don't know much about its atmosphere or composition yet, it remains one of the best candidates for an Earth-like world. The data collected by TESS has fueled speculation that we may find another Earth within the next few decades. The role of James Webb and upcoming telescopes. If Kepler and TESS are the scouts of this mission, the James Webb Space Telescope, JWST, is the scientist. Launched in late 2021, JWST has an unprecedented ability to observe exoplanets in detail, particularly their atmospheres. By analyzing the light passing through an exoplanet's atmosphere, JWST can determine the composition of gases like oxygen, methane, and water vapor, key indicators of life. What makes JWST revolutionary is its ability to see farther and clearer than any telescope before it. It can detect planets and stars forming in distant regions of space, giving us a deeper understanding of planetary evolution. More importantly, it can analyze smaller Earth-sized planets, something previous telescopes struggled with. However, the controversial aspect of this lies in the expectations surrounding JWST. Many believe that it will not only find planets that resemble Earth but also detect signs of life. Others argue that even with JWST's capabilities, finding definitive evidence of extraterrestrial life remains a long shot. Regardless, the data collected by JWST will likely reshape our understanding of the universe and our place within it. The closest candidates, Proxima Centauri b and the TRAPPIST-1 system. When discussing Earth-like planets, two names often come up: Proxima Centauri b and the TRAPPIST-1 system. Proxima Centauri b orbits the closest star to our solar system, just 4.24 light-years away. This planet is intriguing because it's in its star's habitable zone, and its proximity means it could one day be a target for direct observation or even future space missions. However, there's a catch. Proxima Centauri is a red dwarf star, known for producing frequent solar flares, which could strip away any atmosphere and make the planet uninhabitable. The TRAPPIST-1 system, located about 39 light-years from Earth, contains 7 Earth-sized planets, 3 of which are in the star's habitable zone. The discovery of this system in 2017 sparked immense excitement in the scientific community. But, like Proxima Centauri b, TRAPPIST-1's planets orbit a red dwarf star, raising concerns about their ability to retain atmospheres. The proximity of these planets makes them prime targets for further study, and ongoing research will determine whether they truly hold the potential to host life. The challenges of detecting life. Finding a planet in the habitable zone is one thing, but proving it can support life is another challenge altogether. For scientists, the holy grail is detecting biosignatures, chemical compounds like oxygen, methane, or water that suggest biological activity. However, this is where things get controversial. Take methane, for example. On Earth, much of the methane in our atmosphere is produced by living organisms. But methane can also be produced by geological processes, meaning its detection on another planet doesn't necessarily mean life is present. Another complication is that some exoplanets may have conditions that are vastly different from Earth's, yet could still support life in ways we can't currently imagine. Consider the moons of our own solar system, like Europa and Enceladus, which have subsurface oceans beneath their icy crusts. While these moons aren't Earth-like, they could harbor microbial life in their oceans, demonstrating that life might exist in unexpected places. How far away are these planets? One of the biggest hurdles in the search for another Earth is the immense distances involved. Even the closest exoplanet, Proxima Centauri b, is over 4 light-years away. That may not sound like much, but with current technology, it would take tens of thousands of years to reach it. This leads to the question: is it even realistic to consider colonizing or exploring these planets? Projects like Breakthrough Starshot propose sending tiny spacecraft propelled by laser beams to nearby stars at a fraction of the speed of light. In theory, such a mission could reach Proxima Centauri in just a few decades. But these are still early-stage ideas, and the technology to send humans, or even larger spacecraft, to another star system is far beyond our current capabilities. Are we really close to finding another Earth? So, with all this information, how close are we, really, to finding another Earth? The answer is both closer and farther than we might think. On one hand, we're finding more Earth-sized planets in the habitable zone every year. The number of known exoplanets continues to grow, and missions like JWST and TESS are providing us with more detailed information than ever before. Statistically speaking, there could be billions of habitable planets in the Milky Way alone. We may be just one discovery away from finding a true Earth twin. On the other hand, the distances involved make it unlikely that we'll visit these planets anytime soon, let alone determine if they can support human life. Even if we find a planet with all the right conditions, confirming life's existence, or attempting to colonize such a planet, remains in the realm of science fiction for now. The ethics of discovering another Earth. As we get closer to finding another Earth, there's a growing conversation about the ethical implications of such a discovery. If we do find a habitable planet, should we try to colonize it? Or would we risk repeating the same mistakes we've made on Earth, exploiting resources, damaging ecosystems, or even disrupting alien life forms that might exist? Moreover, if intelligent life exists on another planet, what responsibilities do we have toward them? These questions have no easy answers, and they spark heated debates within both scientific and philosophical communities. The next steps in our journey, the quest to find another Earth, is one of the most exciting scientific endeavors of our time. We're closer than ever to discovering a planet that could host life, perhaps even within our lifetimes. With missions like James Webb and TESS, we're on the brink of a new era in astronomy, where the search for Earth 2.0 will yield more data, more candidates, and more questions. Yet, despite the tantalizing prospects, the journey is far from over. The distances are vast, the technologies are in their infancy, and the challenges, both scientific and ethical, are immense. But one thing is certain: the universe is vast, and if there is another Earth out there, we won't stop searching until we find it.